Okay, this problem is from 6.4 Homework Help. First problem. It wants us to graph this function, and this function is y equals 2 sine of x minus 90 degrees, pi over 2. Um, and it's a little hard to read. So there's the function we're trying to graph here. Now I'm going to graph the regular sine first, and I'm going to do this in increments. So let's do 90 degrees and negative 90. We'll do pi, negative pi, 3 pi over 4, and 2 pi, negative 3 pi over 4, and negative 2 pi. All right, now the regular sine function we know looks like this, where it starts off at 0, and then at 90 degrees it reaches its highest value of 1, and then it goes back down to 0 at pi. If you look at your unit circle, it's at negative 1 at 270, and at 360 it's back to 0. So you can just follow this pattern every 90 degrees. So the regular sine function looks like this. Now, we're not graphing the regular sine function, though. We're graphing this one that's got a vertical stretch of 2, which means it changes the amplitude to 2, and it's shifted to the right 90 degrees. So that's the one I'm going to do next here in blue. It's got an amplitude of 2, so it now goes up twice as high, and it is shifted to the right. So this point now would be here. This point that was here now goes over 1, but it's stretched to 2. This point here goes over here. This point goes over to 2 pi, but it gets stretched to negative 2. 1, 2, down here, and so on. So this point goes over to here, but gets stretched down to negative 2. This point goes over 90 degrees. This point goes over 90 degrees, but gets stretched to positive 2. And you get the idea. Now this could be a little tricky in Webwork. You want to click on add points, and then you're just going to add these points just like we have them here, the blue function here. So I'll start at 0, it's at negative 2, so put a point there. And at pi over 2, which is 1.57, it's at 0. And then at pi, 3.14 was up to its highest value of 2. And then at 3 pi over 2, which I had this written wrong on here, 3 pi over 2, I had 3 pi over 4, but it's supposed to be 3 pi over 2. We know this thing reaches back to 0, which is about 4.7. So just follow that same pattern. Negative 1.5-ish, or negative pi over 2, it's at 0. Negative pi, 3.14, it's at its highest value. And then, same thing over here. Now, sometimes if you go to connect these now and you hit submit, it doesn't work. Mine worked there. But if it doesn't, what you might want to try first is allow drag, and drag these to where they're more accurate, basically, because sometimes it's easy to get a little bit off on your points, and Webwork can be a little picky, as we know. So I want to try it a couple times, but hopefully you'll get it. Okay, the next problem is really tricky. It gives us two things here. It gives us this point P it's rotating around, so this is theta here, and this one is theta in terms of t. So as t, it's a relationship between t and theta. So the first problem says for angle theta in radians, a function of time, by the graph in the second figure, what is the value of theta when t is 1? So when t is 1, my value of theta is right here, which is 1 radians. And then they say find the coordinates for p when t is 1. So over here now, if my angle is 1 radian, what is my coordinates for point P right here? Well, just take this triangle over here where you have 1 radians here, and we know they told us for mine the radius was 5, so I want to find the coordinates x and y. So to find the coordinates now for x, we could do cosine of 1 radian, make sure you're in radian mode, equals adjacent over hypotenuse, and we can also do sine of 1 radian is equal to opposite over hypotenuse. Multiply both sides by 5, and what we're looking for then is these values for x and y, which we can do in the calculator. And I get 2.702 about, and 4.207. Okay, the next problem wants us to find the frequency of this. Now, the period is equal to 1 over the frequency, so that means the frequency is equal to 1 over the period. So we just want to find the period and reciprocate it. So now the period is equal to 2 pi over b on our formula sheet. So that's 2 pi over 13 pi in this case, because that's what b is. And so my period is 2 over 13, which makes my frequency the reciprocal of that, 13 over 2. Okay, the next problem gives us a graph here, and it tells us it goes through these 2 points, and it wants us to write a function for this. So I know my function is going to be y, I'll use y, equals a sine of b times x minus c. And I'm not going to, it's plus 0. I don't need to add a d on there because I can tell it's not been shifted up or down at all. So the amplitude then, A, it looks like it goes all the way up to 3, so it'd be 3 sine. To find B, I know that's the period. It repeats every 6 units, it looks like. 1, 2, 3, 4, 5, 6. Yeah, so the period is 6. So the period is equal to 2 pi over B, which is equal to 6 in this case. So if you multiply both sides by B and you divide by 6, you get B equals 2 pi over 6, which simplifies to pi over 3. So my B is pi over 3. And then this is my phase shift now, x minus c. It looks like it's shifted to the right. You know, usually the sign goes like this, starts off at 0, as we know from the unit circle. So therefore, 1, 2, 3, 4, it's been shifted to the right 4 units. So there's my function right there, which I can enter in right here. Okay, let's write another sine function. This time we're going to shift it. So we're going to start off with the sine of x, and we're going to shift it 9 units downwards. Or I'm sorry, to the right 9 units. To the right 9 units would be subtracting 9 from x. Downward 8 units would be subtracting 8 outside. And vertically stretched by a factor of 5 would be changing the amplitude to 5. So this would be my equation right here. Next problem just wants us to look at this graph and give the amplitude, the period, and the phase shift. The amplitude goes all the way up to 4. The period repeats every 2. And the phase shift is 0 because the regular sine function starts off here at 0 and goes up. So it hasn't been shifted right or left at all. Next problem, same thing. The amplitude is the number in front here for the vertical stretch, which is 7. The period is always equal to 2 pi over b, and that's right in the formula sheet. So that's 2 pi over b is 3 pi in this case. So the pi's cancel and we get 2/3 for the period. The phase shift is how much we're adding and subtracting from x. So this is a little bit tricky for this phase shift. What I have to do, because the way that's written, is I actually have to factor out a 3 pi, leaving this with x minus 2 over 3 pi. So that if I were to distribute the 3 pi, I'd get back to the 2 right here. So I'll write this whole thing. So I rewrote this like this so that I can see now my phase shift is actually 2 over 3 pi. 2 divided by 3 pi, and make sure you put this in parentheses. And then the vertical translation is -3. It's shifted down 3 units. All right, the next problem, problem 8, wants us to write a function for this. Now, you can do this a couple different ways. You can use sine or cosine, but sine starts off at 0. So I'm looking at this, I'm going to use the sine here. Now I want to figure out the period. Now the period, the easiest way to figure it out, I guess, is from here to here. Looks like it repeats. And that looks like it's about 6.2, which is about 2 pi. So it looks like the period's 2 pi, so I'm going to try that. So that would be b equals, well, period equals 2 pi over b. And we know the period in this case is 2 pi, so b must be 1. So I'm going to put in 1. And then I also want to figure out how this thing's been shifted. So I'm going to shift this thing over. It looks like it's been shifted. Usually the sign starts off there. And so it's been shifted over this amount right here. So how much is that amount? That's about, if you break this up into 0.4s, because it's 2 divided by 5 increments, then this would be 1.6. Which is about 1.57, which is pi over 2. So you have to kind of recognize that, look for pi, increments of pi, fractional parts of pi. So pi is 3.14 and pi over 2 is 1.57. So it looks like it's been shifted 1.57 or pi over 2 to the right. And so that's my function there. And if I enter that in, sine of x minus pi over 2, that should work. Okay, the next one, when you go to graph this, let's use sine again, and you might notice that that the period of this goes from here all the way to here, which is about 2 pi, it looks like. Again, 6.28. So let's use the period as 2 pi over b, which equals 2 pi, so b must be a 1. And then let's figure out what we've done. So it looks like we've shifted this over because sine usually starts here and goes up, starts at 0 and goes up. So therefore we've shifted over this amount, which looks like it's about pi. So let's shift it over pi right here. So that should be my answer, sine of x minus pi. Okay, the last problem then gives us another sine function. It wants the amplitude and the period. The amplitude goes from -3 to 3, so therefore the amplitude's 3. And the period, pick any 2 points. So I'm going to pick this point and this point that are the same. And then you can say, okay, that looks like about 1.3. This looks like about 3.3. So I can take one of them, subtract the other one. It gives me about 2 for the period. And that works. They're not going to be super picky about that because they know you're eyeballing it from a graph. So looks like the period is 2 and the amplitude is 3.